All right, here we have a problem where we want to solve for or want to get an expression that will represent the total charge of free electrons in the wire using just the terms of A, E, L, and N. Now, in order for us to do that, we need to understand first what are those symbols. So A stands for the cross-sectional area of the wire, L is the length of the wire, E is the charge of an electron, a single one, and N is the number of free electrons per unit volume in the wire. Now, if you want to find out Q, you can start off. Now, if you want to find out Q, you can start off with whatever you're given with. So that being said, let's start off with N, right? So N is equals to the number of free electrons per unit volume. So if I'm going to multiply this with volume, I will be just getting the number of electrons, correct? So N, if I multiply it with A times L, which is basically volume, you will get number of electrons. Okay? So why is this relevant? Since we already have the number of electrons, we just simply multiply it to the charge of a single electron. Charge of a single electron, that's E equals to 1.6 times 10, you're going to get 19. Okay? So when you try to multiply that, we will get now the total charge of the free electrons in the wire. So that's Q equals to NaLe. Right, let's now have in the bottom portion. Here you are asked to just prove that I is exactly equal to NaVe. We can start off with the definition of I, which is charged over time. And we can also redefine V equals to L over time. Make it time is equals to L over V. Right? From this case, we can already solve it. Q, as per the earlier question, is NaLe. So NaLe all over the time, which is LV. So of course, this would cancel out and this would be reciprocate. So that's NaV. So the current is proof that this is the same correct answer. That's how you solve this problem.